Okay, it's 8:03 already. Without wasting any time further, we are starting immediately. Let me just run this, my Postgres environment. So, yesterday we started creating a database management system for an hospital. So, and we're able to create two tables yesterday. And what I did basically was to let us just see how we can create table, how we can create a table, and not only that alone, and how we can link two tables together. Let me quickly just open yesterday's query. So this was the query we used yesterday. By now we should realize that this is how to create a table one, and we if we are linking one table to another table, we need to have a foreign key of a particular table of a particular table in the in of a particular table in the new table we are creating, and we also then need to reference that foreign key to a table, to the table we are linking it with. And in this case now, we are linking it up to a table called hospital ID. And we just created two functions like, okay, in case there is any form of update here, it should be allowed to make that, we should be allowed to make that update. And if we want to delete this table or this column from this table, it shouldn't be allowed. So far we have a record of of that particular column in this table here. So I told you that also is very important features, because it's help us to secure our data, so there won't be any form of data loss or something like that. Now we all started from here, creating our business rule. From there, we created all those scenarios, every possible scenarios that we need to know for our database, and all what we created here, and we stated those conditions clearly. Each room will be assigned only to only one patient. That is the condition here. It may be another thing in your own case. So these are all the conditions we have here, and from there we now see that based on all these conditions, you then need to look at what are the tables you need to create. And yesterday the only table we created was this hospital table and department table, and we were able to link these two tables together. We could just go ahead also, after having this department now, we can then come here again and link up department, this staff, to each department that we have here. We can do that. All we need to do is we just need to create a table just like this department table here. We create the table, we name the table staff table, we list all these columns here. Staff ID will be the primary key, while our foreign key will be staff ID. Immediately we do that, it would automatically link up, and when you check your ELD diagram, you will discover that those things would also be automatically updated there. So those things are very important. They are all very important things that would we need to all know. But before we move on, I just feel like there are some important things that We could also be looking into, when we are creating tables, some very important functions that we can just check together before we move on to start every other thing that we need to do. Before we start creating every other table, I want us to use this example that we have on ground here to just make some scenarios that are very, very important. If you guys recollect, I don't know, maybe it's on the group or a personal message. Someone sent me a message like, um this thing were updated twice, like probably he has submitted a particular hospital and he entered it again, he entered the same hospital again. Yes, it will submit, because the unique identifier that we have here is just this hospital ID. So regardless of, maybe you have the hospital more than once or that, so far the hospital ID is generated uniquely, it will keep on entering. But there are other ways we can go about that actually. But there is one function I want us to look into today. In case, for example, we've created this table, let's run it, let's run this hospital now. We have it here already. This is hospital table. What if we want to, like, okay, this, we want this record to be deleted, so to say, and we want to run our table afresh. So there is a function that we can add at the top here. There's a function we can add at the top here. Let's say we drop, let me zoom a bit so you all can see what I'm doing. Drop table if exists, and you will now put this table name at the upper part here. What you are simply saying here is that if this table exists, you should drop it. And once you get here, you are now recreating the table. Let's see the scenario that we are trying to create here. Let's run this code. Let's see. Yep, we are having a problem here because this table has a what's it called, a foreign key linked up to this table, and that is not working. But let's quickly do something. Let's bring this, the function that we have here. So far is not, this is not relying on any other table. Let's see what we have here. We want to drop this table. Let's run it now. It's showing that we have a syntax error. Okay, let's add this here and run again. Now it's successful. Now what this one simply does is that this table has been dropped and it has been created again. You recollect that we have this record in this table before. Let's run it now. You can see that is now what is now empty. So let's run this one again now. I think so far we don't have that record there. It should run. Okay, we need to have a semicolon in front of that to show that we are done with a particular query before moving to the other one below. Let's run. Yeah, it's still not working because it's linked up to this. But however, what I just want us to know is that All I just want us to know is that I think I've explained the reason why it will not delete. It is restricted here. What I just want us to know is that if you need to drop a table, this is a function that you can use to do that. And there are so many other functions that I would we can be looking into here. For example, we've created this table already. This table has been created already, right? We have these columns here. What if we want to add one additional column to this table? There is a good functions that we can also look into called alter. This alter can be used for different purpose. So the first thing is we can say alter table, alter table departments, alter table departments, um, alter table department. Then we can say below it, we can now write add column, column. Which other column that we can just add here? Let's say add column tests. Add column tests. Let's add our semicolon here. So what we are simply doing now is that we are altering this table. Ideally, this is better below the table because you must have created the table before you can use this alter here. So now we've created the table before. Don't forget, this is what we have as our table. So let's run this code. Now, sorry, what's the problem here? What's the problem? Okay, we need to indicate the data type. Don't forget, when we created all these, they all have data type also. So we need to indicate the data type of the column we are adding. So let's run it now and see what we will get. Yeah. So let's run the table again. Select from department table. What are we having now? You can all see now that we are having the test column in the front here. So that one is useful in a situation whereby we've created our table already and we want to perform some additional function. That is where this alter table is very, very useful. Let us check another thing we can do with this alter table. Alter table again. Alter table. Let us do something like rename column. Rename column. Peradventure you have a column name before, you can rename it. Rename column. Instead of this test now, let's say it should be new underscore tests. It should be new tests, right? So let us run this column. Sorry, rename column. We need to state the column name, tests to column, and in this case we don't need this data type. The column has data type already, so we just want to rename the column from this to this. So let's run this, alter this. Okay, for clarification, let's have this one at the top. Obviously it should come, if you run the code it will work, but just for understanding sake. So let's run it now. Fine, it's successful. Now let's run this select from departments again. What do we have? New tests. New tests. Please, I think, are we together? Can I have a thumbs up or anything for me to just know that we are together? Okay, Thank you. So what we are basically doing now is that we already know. You see, this thing I taught you yesterday here, right? With this idea I taught you yesterday, like just linking one table to another table, we can finish everything we have here. We just build this database management model. So I'm satisfied that I have taught you that yesterday. However, I'm not, I won't be stopping there, but instead of me just continue to start linking tables together, I've taught you already. If you can just be patient, you can do this yourself. Instead of me just going through all the process of teaching you all this one by one again, I just want to teach you some manipulations you can do on your table, which is what I'm doing basically. So I've taught you, you can drop your table, can drop your table if the table is existing. You can alter by adding a new column. You can rename column. And at the same time, you can also drop a column. You can also drop a column. So let's check that. Now, this new test column that we have now, we can drop it. We can just say, okay, come here, alter table department. And what do we then do? We now say drop column, and we just put the table name, drop column, like the column name rather that we want to drop. If we run this code, don't forget this is what we have before, right? Let's run this now. It's successful. Let's run this code again now. What happens here is that that particular column has been dropped. That particular column has been dropped. Do we have anything that we don't understand now? Okay, someone is raising up his or her hand. Can I hear from the person?
Yes, sir. Good evening, sir.
Yeah, you're welcome.
Yes, sir. So, like, basically, now this code that we've been running here, the department. Now, when we drop from departments, won't it affect the ERD? Like from this code we've been running here.
Okay, just watch what we did there. If I drop this department, right, I don't have a table called department in my query again. Let me come here and run this for you. It's not existing again. Sure, you can see. So, but if I come here after dropping it and I recreate it again, right? I have department, and so far there is this relationship. It will also be showing in my ARD. Once you drop it, it's no longer in the ARD, but if you recreate it after dropping it, this is just a step, right? You drop the table and you create. If you recreate it back, it will be showing under your ARD again. So the ARD is just basically tables you have, and that are linked up together will always be linked up together, and you have that relationship that you have there. Do we have any other persons that have questions or anything that is bothering him or her? Okay, can I hear from the person?
Please, this drop that you spoke about, when you are using that drop, is it that you are trying to exit a particular data, or you are trying? I don't really get the drop thing. What is happening like that?
Now, thank you very much. Somebody sent me a message, right? Let's take for example, we are just having an issue here because we linked up this table together already. But basically, what the drop does is that is to delete table, is to just delete table, is to delete table. That's what the drop does in your table. Once you drop the table is deleted. Every content, everything that you've inserted in the table before now, they are all deleted automatically. Do I have anybody that have any contrary thing to say before we proceed? Okay, in the absence of any other um, contribution or anything, I think there is another thing that we can just be looking into. Okay, let me just run this now and we create this table back in our model. We have it back and let me run this. Obviously, we'll just be having those things we created there. I just use all this to explain different functions that we can do. And once we come here, we can run all this. Now, just know this and know it for good. Most of the time, you see this insert is not your problem, so to say, as a data engineer or analyst or analyst, so to say, is not your problem. But just for the sake that we need something to do, that's why we are inputting this data. Ideally, when you create all this model, the engineer or whatsoever, the front end engineer, are the ones that will create form that absorb all this information and you begin to get all this information that you have here. So we are just creating this insert because we we need data to test run what we are doing. Okay, let me hear from that person.
Hi Sam, good evening.
Yeah.
Yeah, quick question, right? This is more like a follow-up to the question I asked yesterday. That's with regards and uploading a pre-existing data through import-export.
Okay, I'm with you.
Okay, so remember the conversation was that we use the same template of the existing table in the database to import the data, right?
Yep.
So does it override the existing data on the database or it adds?
Hmm. That's a very good question. If you are doing that, I like I did mention earlier on, like inputting data, all this is not major problem mainly, but from my experience, I think added, I have not imported data into existing table that has record inside before. So until I try that, that's when I can give you that answer that okay, it would update or anything like that. But from what I have done before is to create a fresh table with the exact column, then import the data. That's what I've done before. So I can't give you a direct answer concerning that currently. So until we try that, that's when I can say. But I doubt if it will work in actual sense. I doubt if it will work. So my advice for anybody that has any work related work like that, like you want to update data upon data like that, what the only thing I can advise that kind of person is that um you can like export the existing data that you have. You can export the existing data that you have and join everything together in your Microsoft Excel or whatsoever platform you are using and upload on a fresh table. You can drop the table, create the whole column again, then upload. Then you have your data in there. But I have not attempted updating data like that. But however, there are other ways of doing that. I don't know, maybe if we've heard of this platform called uh, SSIS also. So SSIS is just like an ETL platform whereby you can create a arbitrary table, a kind of arbitrary table whereby you run functions and you can update record upon record. So that is at advanced level anyway, which is not what I intend taking you through currently. So let's focus on the tasks we have at hand now. So like I mentioned, you can try that, and if you have a good success on that, you can let me know. And you have, probably if you have any error message that you feel you need help, you can always let me know. I will always provide any needed support that you need. Now, the next thing we can do now, probably as we proceed further, I will still be giving you some other functions that may be needed for you at the long run. But for now, let's look at how to complete this ELD diagram that we have here. So the first thing is we've created department. The next thing is let's create staff, the staff of the organization. So we have staff ID, we have department name, and every other information has to do with the staff. So let's come here. What we can do now is we can just always use this. Great. Let me just come below down here. Create this now, and the table name will be staff. Yeah, the person can come up as I just proceed over here. I just someone ask question. Someone raises or hand up. Okay, let me just continue with what I'm doing. Staff ID, like I said, this thing is just repetition of what we have done, but it's just for you to understand the concept. What we are doing now is we are linking this to this. So as we keep on doing it, these things will keep on building by itself. I've just showed you the logic of how to build this whole system already with these two examples that I gave you yesterday. With these two examples, you already have the model of how the whole table will be created. So let's create maybe two more, then I'll push every one of us to go and complete this process for us. So let's do that now. So I'm hoping that by tomorrow, I'll be going through this revision of this old database management system. If I could get 2, 3, 4 persons from you guys that can give me this full model, so I'll be so glad and sit and hope that every other person can do the same. So let's create more so we can just understand the process. Like I mentioned, staff ID will be our primary key, while department ID will now be integer here. They should be integer. The data type should be integer here, and it should be not null. And some other information we have here is just, I'll just pick few staff underscore name. You know, this is text and it could contain anything, so it's just better we use what we call valcar, and we can just use the length 200. A name should not exceed that actually, so we can make it not null, like it's compulsory for us to have it. And we can come down here also and say we need staff phone number, staff phone number. Valcar will give us that also. So also, what other information we think we may need from staff? Staff uh, address, we can just leave it as that. Address may be longer, so let's say 300 will be good for that. And the foreign key here is department ID. So we just come here, have this as our department ID. And where are we linking it to? We are actually linking it to this table called departments. So we are going to come here and pick this table departments here, and the column we are linking it to in that department table is called department ID. I know all these things, but I just intentionally come back to pick them from the table itself. Someone raising up his hand. Okay, nobody. So can you see now? We've linked up this table together, and we can just run this. Let's run this. Fine. Automatically, we have a table called staff now. So let's check staff. Select staff from staff. Can we run this now? Cool. So you can see we have all this information. If we come to our ARD here, objects, create, is it schema now? Is it object or object now? What is happening here? Let's save this to ARD2. Let's see what we have now. What's happening? I may just run all this in here. Or let me refresh this. Okay, I have on my table here now. What's the problem? Why am I not having my okay, let me just use this. Right click on the database itself, ARD for database. Let's see what we have now. So we have the three tables here now, and as you can see from what we have here, you can always click on this. However, from what we have here now, you will realize that this hospital is linking up to this department, and this department is linking up to the staff table here, which is exactly what we have in this distribution. This is linking up to this, and this is also linking up to this. Okay, so now let's continue. The next thing we can do now is hospital also. We have doctor here, so we can create that doctor table also. We can create that doctor table also by coming down here. Let's come down here. Let's zoom here now. Can just copy this again, paste, come down, paste here, repeat the same process. That's why I said with the two tables I created yesterday, you guys can complete this process without stress. And before you know it, you have a database management system for ARD. And this thing you create, it will just be enough to solve the problem. But don't forget, we all started by defining the process, and based on the process we defined, we could identify the tables we need, and we created the kind of ERD diagram here. We already built the relationship that okay, this one will be linking up to this to this to this, and from there we then come back to this code to write all this. So this ERD diagram is very, very important for you to be able, you should be able to create it first before you come to start writing this your code. But as it is, we have it here already. So what we then need to do now is to see, okay, which table links up to which table. And we've created this, we've created this, we've created this. So the next thing we now want to do, we want to create also is doctor. So, and every doctor is also linked up to to departments, to departments also. But for me, I would I would question this, right? I can also question this, that why should we have doctor on their own? I think doctor should also be under staff ID here. So if I want to look into this other way around, I could say that okay, can I have a table called department category? So under this department category, I'll be having nurse, everybody in here like that, in that department category, and that will be linking up to our staff ID. So inside our staff ID, we can then have category ID, but don't let me stress you with that. Let us just stick with the ARD I have here. So for you to just master the process, then you can start thinking of other possible scenarios. So let's create for doctor. Also create table called doctor, and what's the okay, the primary key is doctor ID. That's the primary key. Sorry. And every other thing we have key. Department, we also have department ID as the foreign key, which is what we still have there. I'll leave that. So the next thing is okay, we have doctor name. Let's just do it like this. This doctor name, doctor phone number, doctor address. And in this place, our the foreign key we have here is the department ID, and we are also linking it up to department table, and the column we are linking it up with in the department table is department ID. So everything we have here is still correct. So we can just click on this. Sorry, we can run. Can just run the code. It's successful. So let's run this also, doctor here, and let's run. Now we have our doctor table here also now, and if we come here, we click on our database here, we right click on it, I will click on generate ARD for database. This is to just monitor the process we are creating. Is it following with what we have? So we have our department ID here, and the first thing is department ID is linking up to this table, and it's also linking up to this table. It's linking up to staff table and also linking up to doctor table, which is exactly what we have here also. So we can keep on building on this, on this, on this, on this, on this, gradually, 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 like that. So the next table we can create now is this patient table. We can create is this patient table, and The only foreign key we have here is pharmacy. So before you create this patient table, you can create this pharmacy table. And from there, you can create every other tables that are involved. Do we have any question? Let me entertain questions, because I will be leaving this for us to, for every one of us to just use this knowledge to build on this. So by the time you are done with this, you are done with that database management system. So once, the next thing you can do now is create this pharmacy table, create this patient table, and link them up one by one like that. Let me entertain questions now. I think I've explained what you need to know.
Yeah, yeah, yes, sir. The question I want to ask is there a reason in particular to why you decided that, oh, pharmacy table should be the next?
Yeah, looking at this distribution, right? I just realized that it's just the only table that is um independent, right? Independent, that is not relying on any other table. Every other table has foreign key. If you look at this has a foreign key, this has a foreign key, this has a foreign key, this has a foreign key here also, right? It's the only table that doesn't have foreign key. So once you create this on its own, you can create every other table without stress, because it's the only one that is not linking up with any other table. So once you have it, you can create every other table. Just link them. Just take one step at a time. We have this now. This table has two foreign key. It's not issue. What we need to do is, once you are here, right? Once you are here, that you once you create this first one, just copy, sorry, once you are done with the first foreign key, copy also here and paste and create the second foreign key here. Okay, I think ideally this should always go along with each other. So come here and paste and create the second foreign key. If it's up to 5, press enter, create the next one. So that is how you build on and on and on like that. So that's that. Any other
Yes, sir.
question?
Sorry, sir. I still have another question.
Yeah,
So
yeah,
on
you
the
can see.
so like, what if there's a case where um we've not yet really like created the ERD table, and we want to start like coding everything down. You know, now you said that
Hold
the
on,
formatting.
hold on. You are already asking a question that I've answered. Once you have a database management system, look at where we started from, right? If you have a project, if it is an hospital project like we have, understand the problem that you have. You need to have the basic understanding. Now, if you look at all this, we're saying that, okay, we want to create a database management system, and we need looking at it, we'll be needing these tables. So you need to have the understanding of the problem. From here, you come here to specific users. What are these your who are the people that will be using the database? Here we say it's basically the staff. And I think when we got here yesterday, I emphasized that in your own case, you may feel like it's not only staff. I want a kind of a database whereby even patients can also check their medical record also. It's down to you. So in that place, you're already making decision. So once you are done with that, you come here and start making your business rule. And it is when you are making this business rule that you will be making some very, very important decision. Okay, my hospital table will be linking up to a department table. This is, if you recollect, when we got here again yesterday, I said that at this time, I'm already thinking that I'm not creating an hospital database management that only one hospital will be using. I'm creating a system whereby any hospital can register and use. Everything is solved at this point. And I'm also saying that, okay, this is the table format, date format that I'll be using, so that I will not be having an irregularity or any other thing at the long run when patient comes in and all that. So these are stuffs that you make already. And when you now get here, you now start making decisions that, okay, a doctor can be assigned to more than one patient. A patient can, all these conditions are what you can make. A doctor or staff member will be assigned to only one department. You can only be in one department within the organization. So all these things are what we need to understand from the onset. So when you have all this understanding, that is where you come up with this ERD diagram. I think the issue, one thing that I think I did not do for you is creating this thing itself. There are different tools that we can use for this ARD diagram. I don't think I have it on this system I'm using now. I will share some with you. That we can use different drawing tools to create this. So once you have the understanding, you need to build all this. But mind you, this is just a kind of general overview of what you are driving at when you get to your coding stage. At the point of coding, there may be need for you to readjust what you have here. There may be need for you to readjust what you have here. So if you are coming to code before you do this, number one, you'll be stressing yourself, and number two, you may be tending to do what you don't understand. So it is very, very important for us to go through all the process I showed you yesterday, arrive at this. As a matter of fact, when you even get here, before you get here, there are a lot of processes that you may also be coming into to do. For example, one of them was what I mentioned yesterday, form normalization. I told you yesterday that it's even a special topic that we can take like 4 or 5 days to look into. We have first form normalization, second form normalization, third form normalization, and we have end normalization or something like that. So those are all what you consider before you do all this. However, but with you being a beginner, you can think of something, of a situation. I told you I'll be sharing a school management system I created with you guys. Maybe I'll do that tomorrow for you to just see the real life understanding of what we are talking about. But before you arrive at coding, I will always recommend have your ALD diagram and obituary ALD diagram, just showing that, okay, if I have an hospital department, uh, I will also have a department table, and an hospital can have more than one department, which is what we have here, one to many relationship that we are having here. And from there, we can now then say that we also want to link our department to staff. And what if you look at this relationship, look at this mount here, you can discover that this thing is splitting into three, right? It's showing that this is many. What we are saying is that uh, many staff, more than one staff, can be in a department. So that's why we're having one to many relationship between department and staff. So let us have this understanding very, very well. This ERD diagram is very, very important. If I'm you, I will just take time, sit down and read what this ERD diagram is all about. Just read it on your own to have understanding of what we are really trying to talk about here. So I will not recommend you
Nice.
coming to coding before you do all that. All right, George, you can come on.
Nice. Yes. So I don't know if we could look at this appointment table because it's looking like it has is it two primary keys or one primary key and two foreign keys. I'm not really sure again. The appointment table on that ARD for hospital.
Yes, okay. Let's do that. Let's do that. We have patient ID and doctor ID, right? Before we can get here, we need to create this patient ID so we can have everything in order. So let's quickly just do that now. Let's create our pharmacy table first. Pharmacy. Pharmacy ID. We have our pharmacy ID as the primary key there. Pharmacy name, pharmacy phone number. So we don't need this. Pharmacy address, pharmacy phone number. So this is all for pharmacy while all these are not needed for our pharmacy table. So let's run this code. And then this comma will not be needed here. Now we have that. So the next thing we need to do is to create our patients table. This is our patient table. And the first thing is also our patient ID. So the scenario we are having in this patient table is that every patient have a fixed pharmacy. So here we have our pharmacy ID as foreign key here. So we're just going to have this as integer. We have that as integer. The next, every other information we have is just this patient name, patient phone number, patient address. Now, our foreign key here is pharmacy ID. We have this as our pharmacy ID, right? And the table we are linking it up with is our pharmacy table. So we just come here. So we are linking this to this in our pharmacy table. And with this, we are good. Let's run this also. You can see everything is working well. The next thing we then have is this appointment table that you are talking about. Let's have all this and come here, enter. Sorry, I need to copy this. I don't want to start typing again. Enter. So in this case, don't forget the initial primary key that we have before now was that it will always be in serial. And yesterday I made it clear to you that what this serial does is that it will keep on increasing one by one. If you register a patient, that first patient we have patient ID 1, you register a new patient, it will automatically generate ID 2 for that patient, on and on like that till whatever number of patients you have. But in the case of appointments, our appointments table, let me just change this now to appointments table. What we are using here, we are using a kind of, we call something composite primary key. Composite primary key. That is what we are using here. When you are joining two columns together to form a primary key, it's called composite primary key. But in this case, the primary key will not be in serial any longer. We need to have it in form of an integer. So in this case, this is how you declare your primary key. You will not put it here. Delete this, you will not put it here. And let's come here. The first one we have here, we have patient ID and doctor ID. And doctor ID, patient ID, doctor ID. So just put this as what? As integer also. Now, how do you declare your primary key here? So far is a composite key. But before I declare that my composite key, what are other informations we have here? Dates. So the next thing is dates. And your data type will not be varchar. It will be what? It will be dates. That's your data type. And the next thing we also have here is time. So let's have it here. Time. And your data type will be time. Let me just put this app, appointments, appointment dates, app time. So now, how do you declare your primary key in this situation? Your primary key will be declared like this. You write something like this, primary. Please just follow me. Primary key, open brackets, the first column that is your primary key, comma, the second column that is your primary key. That is how to declare your primary key. But this problem we have here, we are not done with it yet. Don't forget, these two, if at all they are primary key here, they are also foreign key from somewhere else. So you also need to declare them as foreign key here. So what we do next is we have it like this. Copy. Let me start with patients. Copy patient ID here. in here, and our table is patient table. So we are done with this. We would like this to also be aligned with this here. We are done with that. Let's come here again and create this. Our foreign key will now be again doctor here, doctor ID, and doctor here. So we are done. Let's run this now and see what we have. Integer doctor ID. Okay, there is a need for comma here. We need a semicolon here. What is happening here? The comma here also. Yeah. So we have it sorted now. So in this case, for this particular table, your primary key will not increase automatically. It would do what? It will only be increasing. You need to what? To insert this primary key. And you know as it works, right? It must be an existing patient, and the doctor must also what? Be existing. So once you have these two together, you have a primary key. You have a primary key that, okay, and if you have a patient with ID1 and doctor with ID2, that is a unique ID for this appointment table. So if the patient is seeing this doctor again, but from these things that we just mentioned now, I'm already foreseeing a problem, because if I come today for an appointment, right, I meet a doctor. That's why I said it doesn't end here. It doesn't end here. It doesn't end here. This thing will not solve my problem. I need to think of how to solve the problem again with another way. Because if I meet a doctor today and I come back maybe another month's time and I'm meeting the same doctor in the hospital, this will not accept me in. Because let me just give you an example. If I'm a patient, my patient ID is 20 and the doctor ID is 1, right? If I come the next time, this will not change. It will not change. It will still be the same. And this system will not accept it. Because if you recollect, we cannot have two primary key. And this is, it will be saying this as two different primary key, and it will not accept it. So I need to look for a way to solve this problem. So in this case, I may just need to disregard that. Someone have something to say? Do you have anybody raising up his hand? So, like I've mentioned earlier on, it doesn't stop here. But with this, I think I have the problem to solve. And I need to think of a way to solve the problem. Probably, I may just neglect these two as my primary key here. I may just have this as a foreign key and just have a column called appointments, probably appointment ID. Appointments ID as my primary key here without considering this. But I will still leave this here because it's a very good example for us to learn with. Let's check our ALD diagram again. We are 7 minutes ahead of our agreed time, so I'll be stopping anytime from now. You can see,
Uh, Hi, Sam.
okay? Yeah.
Yeah, hi, Sam. Thanks a lot for. I think I've been sort of following what you've been going through. So on that problem, I was just thinking, like, what if we, because I know date is not a repetitive factor. What if we now add another factor to that two we initially had? Would that solve the problem?
Yes, it could. It could. If we feel like if we feel like an appointment should not exceed should not exceed a month. Probably if you book an appointment with a doctor, for example, it now depends on the business problem, right? For example, there are some hospitals, they will say that if you book an appointment with doctor, you pay, right? And once this exceeds, let's say 7 days or something, the appointment is no longer valid again. So we could then start looking at, okay, can we look at how to look at the appointment dates like we have here. For those of us that started this program with us, you recollect that we had a scenario whereby we have age when we look at difference between 2 days. So we could then be looking at, okay, if the difference between 2 days is 7 or something, can then now be looking at into all those conditions that's like that. Or however, we could just use months, like, okay, a particular month in a year, we can add it into this primary key year. So with that, we know that once, for example, let me come back to this place. Let me come back here. Once I have this here, and the month I'm meeting the doctor is June, let's say June 2023, I cannot book another appointment with the same doctor that month again. So this is a primary key. If I'm coming in another month, July, for example, July, that means I'm opening a new appointment. This system should accept this in because they are no longer the same thing. And you know, the problem we're having about primary key is that once they are the same, the system should not accept it. So different things we can think of to solve the problem, or other way around, like I have mentioned earlier on, we could just feel like we don't want to stress ourselves with this problem. We can just say our primary key, the only primary key we are having here is just appointment ID. And in this case, every appointment we are putting in, we just keep on increasing and increasing like that. So just depending on how we can think of how to solve the problem. All right, thank you. Thank you for that contribution, Elvis. Um, in the absence of any other contribution, I want to put it to us, we are to us to just go do it anyhow. Do it anyhow. Build up this system for me tomorrow. Just do it anyhow. The one we just did now, let me show you the ERD that I generated, the last ERD that you can see. So once we generate this ERD, you can just always rearrange it. I will know that my patients need to be at the middle because it's linking up with different tables. So I can also bring my staff. Okay, my staff is just linking up with this table alone here. I can bring it somewhere here. And as you can see, this is my doctor table. I think we created, okay, this is what I'm looking for. So for OSAS, you can see now that we have this as what? As primary key. You can see key on the both column here, right? So that is sorted. We can bring this up here while this can just be within here. Let's drag this here. Let me bring this one up, one down here. Whichever way we feel is okay. And we can zoom a little bit. So you can see it's just straightforward. I want to put it to us to go ahead and finish all these things just with the same format that we have. You can see here also we have two foreign keys here also. Just follow the same example that I gave you here. Follow the same example that I gave you here. Where is it again? Just follow the same example here, where we have two foreign keys here. So tomorrow we are meeting again, and we are not changing the topic. We'll be rounding up, building up this system, this database system. I will be coming to tomorrow to just complete everything we have here for us, but I will appreciate every one of us to go and do this with this knowledge that we have and share it with me. It's just simple. Once you do this, open your mouth anywhere and say that you've been able to build and a database management system for an hospital, and it is generally acceptable. So please, let's do that, and tomorrow I'll be expecting that from us. One more question and we call it a day. And if we don't have any question, I think we can just end it here today. So thank you, Sunday. Thank you, Sunday. Tomorrow we meet same time. I want us to go and do this, please. Go and do this. I'll be starting tomorrow to show us a real life example of all this, using my school management database that I created to just show you how this thing works. It is real. It's not like somebody is coming to cook something up for us. It is real. So let's go and work on this. We meet tomorrow. We focus on this again tomorrow. And from next week, we start looking at joins in SQL. So thank you very much. Let's meet same time tomorrow. Thank you.